Hello and welcome to another video on A-Level Maths Dumbify. Today we are going to start our playlist on mechanics. So this is the first topic in the Mechanics 1 syllabus, and it's called Kinematics. So in today's video I'm going to be doing an example problem on motion of an object with a constant acceleration. A cyclist travels in a straight line from A to B with constant acceleration, 0.06 meters per second squared. His speed at A is 3 meters per second and his speed at B is 6 meters per second. Find the time taken by the cyclist to travel from A to B. Well, the first thing that you have to understand about this question is this is constant acceleration. So whenever you're doing a mechanics question and you see the phrase constant acceleration, what that tells you is we're going to be applying one of these four equations of motion. V is equal to u plus at, v squared is equal to u squared plus 2as, s is equal to ut plus half at squared, and s is equal to half of u plus v times t. I'm sure you're already familiar with these equations, and these equations can only be applied when we're dealing with objects that are moving at a constant acceleration. So in this case, because the cyclist is moving at a constant acceleration, we are going to use these equations of motion. So the first step is always to just draw a short sketch of the diagram. So over here, we have our point A, and the cyclist is cycling to a point B that's somewhere here. So, our cyclist is moving from here to here, and in the question, we've been told that his speed at A is 3 meters per second, and his speed at B is 6 meters per second. So if we come here, so in other words, we know that his initial speed, u, is equal to 3, and we know that his final speed, v, is equal to 6. The initial speed is the speed that he starts with, and the final speed is the speed that he ends with. And then we know that the acceleration is equal to 0.06. So the acceleration throughout the journey A is equal to 0.06. And we are looking for the time taken for the cyclist to travel. We're looking for the time taken for the cyclist to travel. So our question is, what is the time? So we've been given u, we've been given v, we've been given a, and we're looking for t. So which equation of motion here is going to contain these 1, 2, 3, 4 variables? Well, it's the first one. V is equal to u plus at. It has u, which is 3, it has a, which is 0.06, it has v, which is 6, and we're looking for t. So we can arrange that formula to make t the subject of the formula. So t is going to be equal to that, which is equal to 6 minus 3 over 0.06, and that's going to give us 50 seconds. That's going to give us 50 seconds. So 6 minus 3 divided by 0.06 is going to give us 50 seconds. What does that mean? It takes 50 seconds for the cyclist to travel from here to here, from A to B. It takes 50 seconds for the cyclist to travel from A to B. So what that literally means is, if this is our point A and this is our point B, then we know that time t is equal to 0 over here, and time t is equal to 50 over here. So he gets at point B when the time is 50 seconds, and when he's at A, the time is 0 seconds. So that answers the first question. And then the second part of the question is, find the distance AB. Find the distance AB. So again, we are looking for the distance. We are looking for S. We are looking for S. So we have U, we have V, we have A, and we're looking for S. So which equation is going to have these 1, 2, 3, 4 variables? Well, it's going to be this one. It has V, it has U, it has A, and we're looking for S. So V squared is equal to U squared plus 2AS. So what that means is S is equal to V squared minus U squared over 2A, which is going to be 6 squared minus 3 squared over 2 times 0.06. And if we solve that, we are going to get 225 meters. 225 meters for the distance AB. Now, the key thing to understand is that S stands for displacement. What that means is the displacement of the cyclist from A is going to be 225 meters. In other words, if the cyclist is at B, he is 225 meters from point A to the right. So 225 meters to the right from point A, which is just the distance AB. Now let's look at the second part of the question, which says, a car leaves A at the same instant as the cyclist. The car starts from rest and travels in a straight line to B. The car reaches B at the same instant as the cyclist. At time t seconds after leaving A, the speed of the car is kt squared, where k is a constant. Find the value of k. So the first thing to note is that so if I just redraw this diagram here, if I just redraw the first diagram here, where I have my point A here and I have my point B here, this is the cyclist and this is the car, okay? So the first line is for the cyclist and the second line is for the car. Both are moving from A to B. Now, we've been told that the car leaves at the same instant as the cyclist. Well, when does the cyclist leave? Well, the cyclist leaves when t is equal to 0. The cyclist leaves at t is equal to 0, as we saw in our first diagram here. T is equal to 0, t is equal to 50. So the cyclist leaves point A when t is equal to 0, and he gets to point B when t is equal to 50. Now, we've been told here that the car reaches B at the same instant as the cyclist. So when does the car reach B? Well, the car reaches B when t is equal to 50. When t is equal to 50. So the car leaves A at t is equal to 0, and the car reaches B at t is equal to 50 because it leaves at the same time as the cyclist and it arrives at the same time as the cyclist. So if the cyclist arrives at t is equal to 50, then the car also arrives at B at t is equal to 50. If the car leaves at the same time as the cyclist, since the cyclist leaves at t is equal to 0, then the car also leaves at t is equal to 0. So what does that tell us? It tells us that it takes 50 seconds for the car to get to B, just like the cyclist as well. What else do we know? Well, we've just calculated that the distance AB is 225 meters. 225 meters. In other words, it tells us that when the car is over here, its displacement from A is going to be 225 meters. The displacement of the car from A is going to be 225 meters because the car is going to travel 225 meters from A to get to B, just as we've calculated in the previous part. And we know that the car starts from rest, okay? The car starts from rest, so we know that the initial velocity of the car u is equal to 0. Because the car starts from rest, we know that the initial velocity of the car is 0. And then we know that the velocity of the car at any point is given by kt squared. The velocity of the car v is given by kt squared. So this is the piece of information that we've been given. And what we're trying to find is, well, what is the value of k? Well, how do we do this? Well, we look at the information that we know. We know that the displacement of the car when t is equal to 50 is 225 meters. But how do we get the displacement when we've been given the velocity? Well, we know that velocity is the rate of change of displacement. Velocity is the rate of change of displacement, which implies that displacement is the integral of velocity with respect to time. So velocity is the rate of change of displacement, which implies that displacement is the integral of velocity with respect to time. So in other words, if we want to find the displacement at any particular point here, we have to integrate the velocity in order for us to get the displacement. So in other words, if we integrate this, we're going to get displacement is 1 over 3 kt cubed plus c. Okay? Now, c is going to be 0 because when t is equal to 0, s is equal to 0, and c is equal to 0. So what that really means is our s is equal to a third kt t cubed. That is what our s is going to be. So we know from this piece of information here that the displacement of the car is 225 meters when t is equal to 50. When t is equal to 50. So in other words, 225 is equal to a third of k multiplied by 50 cubed. And we simply solve for k. And if we solve for k, we are going to see that k is equal to 27 over 5,000. K is equal to 27 over 5,000. So we simply interpreted our information here and applied the fact that velocity is the rate of change of displacement and solved it to get k is equal to 27 over 5,000. And the next question is, find the speed of the car at B. Well, now that we know our k, we know that therefore our velocity is going to be 27 over 5,000 multiplied by, oops, our velocity is going to be 27 over 5,000 multiplied by t squared, because now we know our k, and we know that at point B t is equal to 50. So our velocity is going to be 27 over 5,000 multiplied by 50 squared, and that's going to give us 13.5 meters per second. 13.5 meters per second. And that's how we solve this particular question number 5. And if we have a look at it, if we have a look at the mark scheme, 50 seconds, 225 meters, 27 over 5,000, and 13.5 meters per second. So that brings us to the end of this video, where we look at an example problem on motion at constant acceleration. If you enjoyed the video, leave a comment down below, like the video, share the video, subscribe to the channel, press the notification bell, and until next time, thank you.